minutes, then the 36 minutes that we are looking for, and then the 40 minutes. This therefore implies that this number falls under interpolation, and we already have these values. 1650. This is what we are looking for. I'll call it A, and then we have 0.1622. We shall use the same reasoning, and the answer we shall get should be able to be greater than this value, but less than that value. It should be able to be greater than that value and less than the other value. Since I have already told you this, it implies that if you wanted to find out the cos, how do you get this? Get this, divide it by 60, and then add what you get on 8 and take the cosine. So using our formula, we shall use that 40 minutes, and because they are minutes, you must indicate that, minus 30 minutes. It is a two-way. We could choose to use that over the next. So we can say over 36 minutes minus 30 minutes should be equal to, we get the value that corresponds to the 40, that's 0.1622. We take away the value that corresponds to the 30, 0.1650, divide it by the value that corresponds to the 36, which we are looking for, that I have let be A, and we take away this value. After noticing this, we are expected to get what it simplifies to. This will be 10 minutes out of 6 minutes, which should be equivalent to this difference. When you subtract those two, you get negative 0.0028 over A minus 1, 0.1650. When you subtract these two and summarize, I'll ask you to summarize by computing. When you compute, you should be able to get the value of A, which I will simply state there. The value of A you'll get should be 0.16332, and that is the value that is equivalent to the cos of 80 that. So we can conclude and therefore say that the cos of 80 degrees, 36 minutes, would be 0.163. Since they are recording them to 4 significant figures, we shall keep it at that. We shall keep it to the degree of accuracy of the question. We shall keep it to the degree of accuracy of the question. The questions we are working through are right over there. I am sure you can see them. And we are done with the first part. The next part, without wasting time, they want us to find the cos inverse of this. Once again, you notice that this is what we have available. And what is giving us this is the x. So relatedly, we look for this value, come back to our table and see where it falls for the second part. 1685. Where does it fall? You see, from 8 it comes decreasing until it reaches that figure. So 1685 should be able to come before this value. And therefore it means it must fall between 10 and 20. It must fall between 10 and 20. So for part 2, as we pick it up, we shall pick a table of our x as 80 and our cosine of x. We shall pick a table between that. The value we want falls between 10 and 20, so we have 10. We have the value, I will call it x, and then we have 20. And we have the corresponding cosines. Here we have 0.1685. For 20 we have 0.1679. And for 10 we have 0.1736. So we are looking for x, and the format or the working is the same. That if I have called it x, I will use, say, x minus 10. These are degrees, these are minutes. So x will be in minutes. Over 20 minus 10. X minus 10 over 20 minus 10 can be the same as our 0.1685. We take away the 0.1736 and divide it by the value on the 20, 1679. We take away the 0.1736. We want the value here for x, so we shall the value for 10, I'm sorry I picked a wrong value here. The value for 10 is 0.1708. 1708. If you make any mistake and you don't see it immediately, definitely the answer you get will be wrong. Usually our degree of conscience is expected to be very high, and therefore when you make any mistake, you ought to see it much faster, else you get a wrong answer. If we make this the subject, we shall get this difference, which will be 10 minutes, multiplied into that difference, which I expect you are getting right now. When you subtract that, 0.1685, you take away 0.1708, you should be able to get negative 2.3 times 10 to the negative 3, and this is divided by 0.1679. 1679, we take away 0.1708. This gives us, again, negative 2.9. Now, this will definitely cancel out. And when we finally get the value of x, it will be 10 minutes plus. When we simplify that, we shall have that giving us 7.9, giving us, that is 2.3 divided by 2.9 times 10. We shall get 7.931. Because the values we have here are recorded to 0 decimal places, we shall get the value of x as 17.931, which we shall approximate to the next whole number, so it will be that. And therefore, we must conclude by stating the final angle. We therefore conclude that the cos arc of 0.1685 is going to give us, we get this value and add on the value we have got, so it will be 80 degrees 18 minutes. You must conclude, otherwise if you don't, you will lose a mark over there. That gives you the final answer for that number over there. You must conclude. Take note, you must conclude. This brings us to the end of number 4. And we have number 5 to try out. You can capture that solution. And you don't need, from here, you don't need to show the next working. You can use your calculator and get to there, get that, and then conclude and give your final answer. We shall be looking at number 5. As you finalize with that, allow me to include my table for number 5 right over here. I will adjust this. I want to thank all the students that continue to work through the exercise questions and those that are actually able to share their answers with me. I have not let you down, and I am sure you continue trying out other numbers with greater confidence than the rest of the students. Number 5 has x and what we can call lean or natural log. It has x and what we can call the natural log of x. There are reasons why I have to do these examples, because if you meet such numbers that require this approach without getting guidance, it can actually prove to be very difficult for some students to get going. So we have this number over here, 4.1, and we have the natural log, 0.4055, 0.90555, 955, and then we have 1.3083, and then we have finally 1.4110. This number, they tell us to find the lean of 4.5, and part 2, they tell us to find e to the power 1.0986. They are saying it is an extract of lean, which we are calling natural log. As we prepare to work through, I can let students know this is not part of what you need for this solution. I mean specifically for the solution, but you need to know this information. That lean of x can be written as the log to the e of x. The log to the e of x. And I can say that if I have log to the e of x, say equaling to a, it implies that x to the power a is equal to e. Let me call this xe. It implies that e to the a is equal to x. So when we go to part 2, you'll definitely note that it is asking us to look for the value here. In other words, for part 2, we are provided with the value we are provided with a, and they want us to find, we are provided with a, they want us to find x. For part 1, we are provided with x, they want us to find the lean of x. So in our solution, we look at 4.5, and 4.5 falls beyond there, so we shall use an extrapolation. We shall use an extrapolation, which means that we can look at 3. X, we can look at 3.7, 4.1, and 4.5. That will be the part of the table that we shall extract, and then we pick the lean of 3.7 is 1.3083, 4.1 is 1.4110, and we can call this B. let the ln of 4.5 be equal to b. We are supposed to look for b. Using extrapolation, we simply substitute in. We simply substitute in to find what is required. If we substitute in to find what is required, we shall definitely use the values available to look for the value of b. We shall use the values available to look for the value of b here. If I take this and this and this and this, I can say this is the ln of x. I can say that 4.5, I take away 4.1 over 4.1, I take away 3.7, should be equal to the value of b which we want, minus 1.4110 over the value of 1.4110, which corresponds to the 4.1 minus 1.3083. So if we simplify here, we shall get 0.4 over, when we subtract this, we shall get 3.7, 4.1 minus this, we are getting this. That is 0.4 also. Is that 0.4? And here we have b minus 1.4110 over. The difference here will give us will give us 0.1027. This 0.1027 if we add on, because this is 1, if we cross multiply, we shall get our b finally if we cross multiply, we shall get our b minus 1.4110 will be equal to our 0.1027, implying that the value of b will be equal to, when we compute, 1.5137. But because these values are recorded to 5 significant figures, we can therefore conclude and say that the ln of 4.5 is indeed 1.5137 to 4 dPs. The ln of 4.5 will give us that as our value that we actually need for this case. For part B of that number, we will repeat the same thing. We will repeat the same thing. I have already told you that if I took this case, the log to the e of 4.5 is equal to 1.5137, implies that e to the 1.5137 is actually equal to 4.5. So if we look at this, we are given this part, which is the ln part, and we want to find the x. So for part 2, since this is 1.0986, we look for where it should be, and we will discover that it falls between these two, because 1 comes after 0.9. So we shall have our x and ln of x. So our situation will start from 2.6, And we are looking for the value that will appear here. I'll call it C. The value of 2.6 is 0.9555. The value here is 1.0986. And here we have 3.7. And the value here is 1.3083. So using the same arrangement, we can start from C. C minus 2.6 over 3.7 minus 2.6 will be the same as the corresponding value, 1.0986 minus 0.955, and we take away 1.3083 minus 0.955. Using your calculator once again, we summarize that part. We summarize that part. To get our C minus 2.6 to be equal to the difference between this denominator is 1.1 times this ratio. So the value of C will be 2.6 plus what we get there. What you get here is 0.1431 of 0.3528. When you compute that, it will give you 0.446, we can call this 2. Therefore, the value of C will be 3.046. But since these values are recorded to one decimal place, we shall say this will be approximately 3.0. And we can conclude and say, hence, our E to the power 1.0986 will be equal to 3.0. The value will be that to one decimal place. The value of that, which we called C, is 3.0 to one decimal place. Yes, those who are capturing that work, I expect that you are moving on very well and you have added some value on what we expect you to learn. You have added some value on what we expect you to learn. And that definitely brings us to the part that brings us to the close of the first part of interpolation and extrapolation. We want to use the remaining part of our lesson, proceed in that line, and look at yet another method. That I will call estimation of roots to equations of the format or of the form of f of x is equal to 0. I'll be clearing this side so that we can proceed. And introduce our next part of the lesson. The next part is estimating of roots. You can call it estimation of roots to equations estimation of roots to equations of the form of f of x is equal to 0. And this one looks at particular methods. There are several methods. There are several methods for the bit of theory, but we shall look at the first method being the analytical. The analytical method, and again using the knowledge of linear interpolation. Equations of the form f of x is equal to 0 are not new to S6 students and some senior 5 students, especially those that are reading ahead. We know that if we have a quadratic equation of the form of f of x, I will take a quick example. That this method will help us to identify or locate the interval. The interval means the region within which the roots which we call the solutions of an equation lie or lies. After identifying the region where the roots lie, we shall also use the interpolation, the knowledge of interpolation we use the interpolation knowledge to actually confirm the actual root, to get the approximate root. There are two important points to note. Number one, that if the root to the function, which we are calling f of x, is xp, then f of xp should be equal to 0. In other words, when we substitute xp in the given function, we should be able to get 0. And number two, if the root lies between two values, if the root of the function f of x lies between x is equal to a and x is equal to b, then f of a multiplied by f of b should be less than 0, or that particular point number b, or number 2, that f of a times f of b should be less than 0, or there should be a change in sign. Between f of a and f of b. That ideally is what this means. that if you put in a as the function, as x, the value you get when you multiply it with the value you get when you put in b, the value you get should be negative. The value you get should be negative. That implies that the change in sign I'm emphasizing there is that either f of a will give you a positive value, and if f of a gives you a positive value, f of b should give you a value less than 0, such that the product is always less than 0. Such that the product is always less than 0. The change in sign here can further be emphasized. I can use two different graphs to show you that if I have a function f of x and you're sketching, the curve would run like this, and if I sketch the second curve, that means the root will be this one. I will show you. And if the root is this one, it would imply that if my value, say a is here, then the corresponding value can be somewhere there. Then if I have, if this is the function f of a, this would be a. Now if this is f of b, this would be b, meaning that this is a negative and this is a positive. And the root would be the point. The root will be the point where the curve for the function f of x crosses the x-axis. Crosses the x-axis. On the other hand, if we consider a change in the function, again, if this is the function f of x and this is x, the root will be here. And we can consider that if this is f of a, then the value of a would be there. And if this is f of b, then the value of b can be there. So the root will also be at that point where this curve will meet that axis, implying that the f of b here, that corresponds with a function that, okay, we can bring it up somewhere there, that corresponds with a value here, which is b, is still negative. This function that corresponds with this is negative and this is positive. So the values where it interacts or it crosses the x-axis would give it the root here and the root here. I think that information is enough for the candidates following this lesson, to allow us to now look at an example. It is very clear that f of a is positive here and f of b is negative here. Very clear that f of a is positive here and f of b is negative. And therefore the product of f of a, as I conclude, I will say that if the root lies between a and b, as I have already emphasized, a is here, b is here, and this is the root. B is here, a is here, and this is the root. Then we have said that f of a times f of b should always be less than 0. This is the condition. This is the condition. And it implies that if you put f of a in the function, it should be able to give you 0, the f of the value of the root, f of xp. Now this is xp, which we call the root. F of xp should always be equal to 0. We can look at an example now and see how this theory works. We can look at an example, but I want to emphasize that you need to know these 2 points. That if the root to the given function is xp, then when you feed in that value, which we are calling the root, f of x must collapse to 0. And if the root lies between a and b, when you feed in a, you must get a value. When you feed in b, you must get a value. But the product of those two values should be a negative, should be less than 0. And less than 0 directly means a negative. Directly means a negative. Less than 0 directly means a negative. Example 1, show that the root of the equation, the equation is 3x cubed plus x minus 5 is equal to 0, lies between 1 and 2, and hence find the approximate root. The approximate root to 2 dp's. The degree of accuracy is very, very, very important. And these questions are very brief. They are typical of section A, and if they had come in section B, they will come with an additional part that we shall be seeing in our preceding lessons. They will come with an additional part that we shall be looking at in our additional lessons. I will request that this time the questions are not coming direct on the screens, as I did not type them, so you can quickly capture that so that we can work through the solution as we progress. The function is given as 3x cubed plus x minus 5. I need to reconfirm that that is exactly the expression. They are saying the root lies between 1 and 2. And they want us to show that the root lies here. So we shall use x as 1 to get f of 1. As I've just shown you, f of 1 will be 3 into 1 to the power 3 plus 1 minus 5. And if we compute, this is actually 3 plus 1 minus 5. And this will give us negative 1. With x as 2, f of 2 will give us 2 cubed plus 2 minus 5. Very simple steps. Here it is your calculator or your head that bills you out. 2 cubed is 8. 8 times 3 is 24. 24 plus that is 26. Minus 5, we get 21. So I can say that my f of 1 is negative 1. My f of 2 is 21. And I'll say that since f of 1 times f of 2 is equal to negative 1 times 21, which is less than 0, then the roots lie. The root actually lies between 1 and 2. The product gives us a value which is negative 21 and which is less than 0. But they want us to go ahead and actually find that value. They want us to go ahead and find that value. To find the root, we use the interpolation that I talked about. We have 1 It is clearly interpolation because the root lies between 1 and 2. So we have, since the function is in terms of x, we will have x and f of x. And for 1, we got our f of 1 as negative 1. The root must lie here. I called it xp. And the 2 is here. For 2, we got negative 21. We got positive 21. And for this value, if it is a root, that value must be 0. Recall, those of you who know how you handle polynomials or quadratic equations, f of xp, I've told you, must be 0. So using interpolation, quickly we can say 2 minus 1 over xp minus 1 will be equal to 21 minus minus 1 over 0 minus minus 1. We are looking for xp, and therefore my xp minus 1 will become 1 times 1. I am cross multiplying here. It will become 1 times 1 divided by 22. And my xp will definitely be 1 plus. It must be between 1 and 2. 1 plus 1 over 22. And because they told us to find the root to 2 dp's, I will use a calculator to find the exact value and simplify it to the decimal places required. 1.04545. To 2 dp's, we shall say that the value of x, the root, is going to be 1.05. 1.05. This will be to 2. The degree of accuracy should be put in brackets. The value of the root should be exactly that. Should be exactly that. The value of the root should be exactly that. I think, my dear students, as you take note, this is just as simple as drinking water. And I usually tell students that it is as simple as drinking water because before you swallow, part of the water will have already gone. Before you swallow, part of the water will have already gone. I want to put our second number. Remember very well, time is not a good ally. Allow me put our second number. And I am very sure that even if we don't complete it, you will be able to do it because already the confidence has been built. I will not rub off the solution because I know some of you are still capturing it. But immediately I finish writing our second example, I will definitely clear the board. Example 2, they are telling us to show that the equation is e to the power x is equal to 4. The sine of x has a root between x is equal to 0.5 and x is equal to 1.5, and hence find the approximation, the approximate root. So it is just an interswitch. If you notice, it is just an interswitch. That here they gave you the roots and they asked you to confirm. Again, here they have given us the roots and they're asking us to confirm. As a senior science teacher, I must mention that one of the things that normally scares off our science students from excelling, not all of them, some from excelling, is the fear of the symbols used, the fear of the diagrams, the fear of the experiments, and Once you are able to overcome that fear, you will definitely find these things right. Quickly, our function should be picked out. Now our function is this. We pick it out by subtracting this there, and we write it in this format. That becomes our function. To show that a root lies in between, we shall say that at x as a half, we put in our f a half, and we shall get e to the half minus 4, the sine of a half. This is where I must emphasize that this, because a half is a very small angle, will require you to use radians. Radians is a mode on your calculator that you must use, and when you use radians, I can assure you that f over half will give you a value of negative 0.2690. At x as 1.5, which we can write as that, we will again put f of 3 over 2. The technique here was arranging the function like this, and then knowing that you must use radians. F of 3 over 2 will be e to the 3 out of 2 minus 4 times the sine again of 3 out of 2. Ensure that your calculator is in radians, and this time f of 3 out of 2 will give you a value of 0.4917. And since this is negative and this is positive, that automatically shows that since your f of a half times f of 3 out of 2 is less than 0, then a root lies. A root, you conclude, a root lies between the two given values, between a half and 1.5. You conclude that. Again, to find the approximate root, the approximate root lies between that and that. So you have your x and your f of x. We will not be able to finish this, I'm sure, but I will simply interpret it. So if the root lies in between here, we called it fxp, but you can call it any letter. You can call it any letter. And importantly, note that the value here we have got is 0.26, negative 269. The value here must be 0. This one is very important. And the value here is 0.4917 at 1.5. So using your interpolation, you will definitely be able to get the value of xp. I want to encourage you to work through this to get that as the value. 85362 will be the exact root or the approximate root. I will not be going so much beyond here, but since we are still having a few minutes, I will tell you to try out. Try out. I will summarize this, don't mind. If f of x is ln of x, the function is ln of x is equal to 2 minus x. Show that it has roots. The roots are between. Show that it has roots between 2 and 1. This is the function. Show that its roots lie between 1 and 2 and find the approximate value. You can also look for several other numbers, especially from the question bank, USCE. I want to thank those that are following me on YouTube, and I want to continue encouraging you to continue revising. The teacher is Teacher Kakuru, and I want to wish you the best. Keep reading. God bless you. Kachali Mabaga.
somera mu ddiiro lyo ng'ewagiddwa. Maryland High School erisangibwa Entebbe, ssomero ly'abawala n'abalenzi. Tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisangibwa mu kifo ekiweweevu obulungi. Tulina ebisuula eby'omulembe, science laboratory ssaako ne computer lab.
Owange gyebaliku okuteka ku ssente leero munyoluka mmotoka yo olinnya lifuti oba okute ku mapesa ga kompyuta yo ku mulimu olinago okutekwa mu ngalo oba ku ssimu yo yennyini weetaaga skin guard hand wash soap ne sanitizer. Linda ku katono tunuulira engalo zo oziraba oyinza okuba okutte ku kintu ekiriko obuwuka bwa coronavirus kubanga busobola okwekwekako okumala essaawa nnyingi nnyo. Kati nno wulira amawulire amalungi weetaaga skin guard hand wash soap ne sanitizer mu mikono gyo mu bibatu wakati w'engalo ne mu njala zo. Weekuume ne Skin Guard. Skin Guard is a brand of Mobit Products Limited.
Maryland High School erisangibwa Entebbe, ssomero ly'abawala n'abalenzi. Tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisangibwa mu kifo ekiweweevu obulungi. Tulina ebisuula eby'omulembe, science laboratory ssaako ne computer lab. Abasomesa baffe abatendeke mu kusomesa n'okubangula abayizi, kuno nga twongerako n'okukulembeza ebitone. Kati nno ggwe omuzadde omwana wo mulete mu kifo kimu kyokka ekigenda okumuyamba okwongera okunnyikiza ebyo by'asoma era ng'essomero liri limu lyokka ye Maryland High School erisangibwa Entebbe. N'okumanya ebisingawo tukubire ku nnamba z'essimu ez'owammanga.
Okwewala oba okwekuuma akawuka ka COVID-19 akalumya ensi yonna. Bino wammanga byolina okukola okuziyiza okusaasaana kw'akawuka kano aka COVID-19. Naaba engalo ng'okozesa amazzi ne sabbuuni buli kadde. Weewala okubeera mu bantu abangi buli w'obeera. Weewala okukwata mu maaso, ku nnyindo, ku mumwa n'engalo nga si nnyonjo. Kolola oba nyiza mu nsonda y'akakokolako oba okozesa akatambaala bw'omaliriza okasuule mu dustibini yo. Bw'ofuna obubonero obulaga COVID-19 sigala ewaka okubire aba Ministry of Health ku 0800-100-000-666 oba ku 0800-2030-33 okufuna obuyambi. Wabula bw'oba oyagala kuzza bujja intaneti yo eya Rock Telecom, kozesa emikutu gyaffe egya digito nga Mastercard, Visa ne ba agent. Osobola okunyiga *252#. Sigala ewaka, sigala nga weekuumye, sigala ku Rock Internet.
Rock Telecom.
Bakasitoma baffe bonna abali ku mpeeza Sente Mobile kati basobola okugulawo Sente Express